You are listening to The Vocal Technologist. Spoken tech for your ears.
It feels like just yesterday, the biggest challenge, the thing everyone talked about, was finding that perfect algorithm, right? Or tweaking some hyperparameter.
Yeah, that was the focus.
But now, honestly, every single conversation I have, it's completely pivoted. It's like, it's not really about the model anymore, is it? It's about the underlying architecture.
The plumbing.
Exactly. The pipes, the valves, the reservoirs holding the data. This whole data landscape, it's shifting so fast, it feels like faster than we can even hit refresh on a dashboard. And, frankly, what we're finding, that everyone's finding, is that AI often fails, not because the deep learning model is somehow mathematically flawed,
Right.
but because the data that's actually fueling it is, well, poisoned or incomplete or just plain organized wrong.
That really is the central truth, isn't it? We have to face it. And that kind of defines our mission today, I think. We're really assessing how organizations are making that difficult journey from what are often just, massive data messes. Those data swamps we all know and love or hate, moving towards truly AI-ready data products. And we're covering the whole stack here.
Oh.
Everything from, exotic, high-performance cloud networking setups right down to the really critical upgrades happening in basic SQL foundations. It's a complete look at that data foundation powering modern systems.
Okay, let's unpack this then. Let's start right there at the foundation. When we talk about the primary friction points, the things stopping these ambitious AI projects, it almost never starts at the model layer itself.
No, it's rarely the model initially.
It's always the input.
Yeah.
And we've kind of identified, 4 major systemic barriers that just seem to halt progress?
Yeah, 4 big ones.
Right.
And these barriers, they're lethal when you try to scale because they just erode trust completely. First, you've got semantic ambiguity. I mean, everyone calls the same column something slightly different, right?
Classic problem.
Then there's just obvious poor data quality. But the trickier ones, the more subtle issues, are things like temporal misalignment. Where your data flows, they aren't time-aware, and events seem to happen out of order, which is, well, it's lethal if you're trying to calculate, say, real-time user state or conversion funnel accuracy.
Completely breaks it.
And finally, just inconsistent formats, constantly forcing engineers to write, bespoke parsers for every little thing.
So if our systems are just riddled with these kinds of issues, you can't just sprinkle some magic dust on your old ETL pipelines.
Yeah.
Extract, transform, load, and call it fixed, right? What's the necessary shift? What do we do?
Well, the shift isn't just tactical, it's foundational. Organizations really have to start treating data as a governed product.
Okay.
Yeah. And this requires what we're starting to call AI native pipelines. Pipelines where validation and compliance, they aren't some afterthought you tack on at the end. They're built in from the start. You need standardized schemas and, critically, those time-aware flows we mentioned to really ensure reliability and, importantly, reusability across multiple AI systems. Because if the data isn't reliable and reusable, it's just not a product.
Got it. So if governing data is step 1, then retrieval augmented generation, or RAG, well, that seems like arguably the most common destination for that nice, clean data these days.
It really is.
We see RAG just dominating as the core pattern for delivering, relevant contextual documents directly to the LLM right when it needs it during inference.
Yeah, RAG is definitely the heavy lifter in a lot of AI engineering today. But, and this is a big but, its success hinges entirely on the architectural elements around it.
Okay.
You absolutely must decouple your data ingestion from the inference process. Otherwise, your real-time performance just suffers immensely.
Right, they interfere.
Exactly. And robust RAG, it requires supporting proper dataset versioning, making sure you can reproduce every single experiment, and treating observability, the logging and monitoring of that whole retrieval process, treating that as a first-class citizen. Because if you can't debug why the system retrieved the wrong chunk of text, your system's going to be unreliable. It's going to be useless, frankly.
That makes perfect sense. But, okay, even if we have clean version data, we run into the physics problem, right? How do we move these massive data sets quickly enough to actually train and serve these big foundational models?
Yeah, speed.
This is where it gets really interesting for me. Once the architecture is sound, the next fight is just this race for speed, all the way from the network layer up to the file format you choose.
And the impact of that hardware configuration, especially on distributed LLM training, it's just decisive. It's far more impactful than most practitioners probably realize.
How much are we talking?
Well, benchmarks comparing highly optimized settings versus just the default cloud configurations showed these massive speedups. We're talking a 6 to 10 times acceleration.
6 to 10 times. That's incredible. But okay, let's be realistic for a second. Is something like InfiniBand even feasible for, say, a mid-market cloud deployment? Or is this really advice just for the hyperscalers, the really big players?
Well, it definitely depends on the scale, obviously, but the principle applies to anyone running distributed training at a certain level. The defining factor in those benchmarks was the networking hardware.
Just the network.
Swapping standard Ethernet for InfiniBand, which operates at a blistering 400 gigabits per second, that's what delivered that 10 times faster training.
Wow.
So for heavy training workloads, you really have to prioritize that layer. And furthermore, just optimizing the storage infrastructure that cut the critical checkpointing time, saving the model state during those long training runs, it cut that time in half. You just can't code your way out of these physical limitations sometimes.
Right. Physics always wins eventually.
Yeah.
Okay, so physical speed is one thing, but what about the data container itself, the format?
Yeah.
We have some exciting material on a new system, Spiral, which uses this Vortex file format to address these really intense AI workloads in what they're calling the third age of data.
Yeah, Spiral is interesting. It's designed specifically to maximize the throughput of modern accelerators like the NVIDIA H100s everyone's trying to get their hands on.
And compared to Parquet, which is widely used, Vortex delivers 10 to 20 times faster scans. And get this, a truly stunning 100 to 200 times faster random reads. Hold on a second. 100 to 200 times faster random reads. That sounds almost like marketing hype. But if it's actually true, what fundamental paradigm does that change for? Like the average data scientist who's just used to waiting on Parquet scans?
Well, it potentially changes everything about latency. It's built specifically to enable direct S3 to GPU data transfer.
Ah, okay. Skipping steps.
Exactly. When you can skip those middle steps and fully utilize the memory bandwidth of your H100s, you fundamentally eliminate that data bottleneck that previously just capped your performance. So if you're struggling with, low latency analytical queries or really fast retrieval for RAG, this is the kind of direction things are heading. This is the future.
That's a huge potential lift. Okay, now, for those of us, maybe the majority of us, who live and breathe Apache Spark every day, even if we can't just swap out our file format today, tuning is still vital, right? What are the key takeaways for maximizing the performance we can get out of existing Spark setups?
Oh, absolutely. Tuning is critical. And the most common mistake, honestly, is mismanaging Spark Shuffle partitions.
Yeah, always tricky.
It is. Too few partitions and you risk memory overload, tasks failing, slow stages, too many, and just the scheduling overhead itself crushes you. The golden rule, sort of emerging from practical experience, is to aim for roughly 128 megabytes per partition.
Okay, 128 megs. Good rule of thumb.
It seems to be the sweet spot, that balance, and always, always utilize adaptive query execution, AQE.
Right, let Spark help you.
Exactly. AQE helps automate a lot of these adjustments, and it can prevent those nasty skew issues that just tank your job efficiency.
Good tips. Okay, let's pivot a bit away from the infrastructure optimization details and look at how some massive established tech companies are upgrading their internal foundations.
Yeah.
This is where you see the real strategic commitment, I think.
Yeah, absolutely. Take Pinterest, for instance. They moved away from their aging Hadoop-based system called Monarch to a next-gen data processing platform they built called Mocha.
Mocha, okay.
And this wasn't just some simple ETL migration, lift and shift. This change drove these sweeping, really complex infrastructure modernizations across the board.
Like what?
Things like moving to proper AWS multi-account setups, completely overhauling their networking topology, and importantly, enabling their EKS, their Elastic Kubernetes Service adoption for all those specialized tools like Flink, Ray, and PyTorch that modern ML relies on.
Wow. I mean, that transition, that isn't a weekend job, is it? That sounds like a multi-year, multi-million-dollar commitment.
Oh, easily.
Yeah, it really shows how serious this shift toward governed AI-native pipelines is becoming across the industry. But this push for modernization, it does highlight an inherent architectural challenge, doesn't it? We rely really heavily on systems like Apache Iceberg for our lakehouses, But what happens when the data changes too fast?
That is the exact friction point for traditional lakehouse architectures. Immutable systems like Iceberg, they struggle with those high churn, low latency updates.
Right.
When a dimension, let's say a user profile field, or maybe some entity that evolves really quickly, when that changes every second, the traditional append-only structure, it just struggles to maintain temporal correctness and scale the whole change management process efficiently.
So if I, update my user profile 50 times in a minute,
Yeah.
Iceberg starts to have trouble keeping a clean, accurate history of that.
It begins to struggle with the sheer complexity of keeping that history correct and performant, especially at massive scale. And this ties directly into the future of agentic AI. Well, think about it. If you have AI agents that are constantly generating content, learning from interactions, that traditional vector store context we use for AUJ, it starts to break down when the agent-generated content begins to outpace the human-generated data.
The context gets stale or overwhelmed.
Exactly. So the solution seems to be moving beyond just static vector context. Leading implementations are now starting to integrate vector databases with graph databases.
Vector and graph. Interesting.
Yeah, to enable this sort of evolutionary feedback-driven memory, this layering, it seems essential if you want to deploy fleets of persistent stateful agents that can learn and adapt over time.
Okay. Before we get totally lost in graphs and vectors, what about our beloved SQL staples? Are they keeping up with all this architectural change? Are we still getting improvements in good old relational databases?
Oh, absolutely. We're seeing some big wins in new database releases. Take DuckDB 1.4.0. They introduced major security and utility enhancements, which really signals its maturity now.
What?
Well, we're seeing actual database encryption using AES 256. That's huge for security, especially if you're using it for embedded analytics or distributing data.
Yeah, definitely.
Plus, the much requested merge statement, finally, makes upserting data so much easier. And they also officially introduced a long-term support model, an LTS model, which basically confirms its readiness for serious production use.
That's great news for DuckDB fans. And Postgres, still the king of extensibility and reliability, right? We looked into the upcoming Postgres 18 release. What kind of performance tweaks are we seeing there?
Postgres 18 has some potential game changers, focused purely on throughput. They've introduced asynchronous I/O.
Async I/O, okay.
Yeah, for faster read operations. Especially beneficial for sequential scans and bitmap heap scans. Additionally, they have adopted UUID v7.
UUID version 7. What's special with that?
It provides much better index locality because it's time-ordered, unlike older UUID versions. This makes indexing massive datasets, especially on time series keys, much, much more efficient.
Better locality. Got it. And I heard they fixed a major limitation with multi-column indexes.
Yes. The B-tree skip scans. This is a massive flexibility gain. It means if you have a multi-column index defined on, say, country, state, city, you can now still use that index effectively, even if your query only filters on city.
Oh, wow. So you don't need the leading column in the where clause anymore.
Exactly. It can skip over the leading columns if needed. That's a massive performance win for queries that previously couldn't use the index properly.
Okay, that is a big deal. So we've been discussing how to build it, how to speed it up, maybe here on The Vocal Technologist.
Yeah.
What does all this mean for, say, the business leader? If we implement all these governance changes, these speed improvements, how does the business actually measure the ROI? How do they know it's working?
Yeah, that's the crucial question. We really need to move beyond just simple output metrics like number of pipelines built. The focus has to be on exposing the friction points across the entire engineering lifecycle. Data leaders should really be tracking maybe 6 critical KPIs that span from intake all the way to resolution.
What do they think?
The percentage of requests tied directly to clear business value that helps stop just busy work. Then planning accuracy, time to delivery for new data products, the overall pipeline success rate, time to resolve incidents when things break, and critically, the data product reuse rate.
Okay, let's stop on that last one for a second. Why is the data product reuse rate so critical for measuring governance success?
Because if nobody actually reuses your beautifully clean, governed data product, you've essentially failed the governing step. Not because the data itself is bad, but maybe because your governance system is too cumbersome or the product simply isn't discoverable or easy to integrate. A low reuse rate tells you, hey, we built something perfectly clean that nobody can actually find or use easily. That's a failure of the system around the data.
That's a great point. Okay, and finally, zooming out to the bigger picture. This entire transition, this focus on governed data products and warehouse intelligence, some are calling it the end of digital analytics as we knew it, right? The old world built on just click attribution and tools like GA4.
Yeah, that model, the simple click attribution model, it's really collapsing. It's just no longer reliable or sufficient for understanding modern, complex customer journeys.
So what replaces it?
The successors are rising pretty quickly. First, you have fast operational customer experience optimization that's about real-time feedback loops. And second, and this is key, warehouse-driven revenue intelligence.
Revenue intelligence. Tell me more.
This intelligence relies on having robust identity stitching in your warehouse, retroactive event pipelines, all built on those governed data products we've been talking about. And the goal is to surface actual churn risk or expansion signals. It shifts the focus away from just reporting vanity metrics.
Like clicks or page views.
Exactly. Shifts it towards driving measurable revenue outcomes based on trustworthy, governed data. Okay, the core takeaway then for everyone listening seems crystal clear. The mandate today is this really strategic shift, moving away from reactive data management, cleaning up messes after the fact, towards proactive, governed data product management. And this governance, it seems, is what drives both that incredible speed we discussed and the measurable business value we just outlined.
Precisely. And as organizations adopt these AI-ready data products, it's really crucial to remember that regulatory compliance isn't just a localized problem anymore.
Good point.
The EU AI Act, for example, has set the world's first comprehensive, enforceable AI regulation. Now, while the U.S. is currently using more of a patchwork of state laws for any multinational organization, the most strategic path forward might actually be adopting what you could call an EU plus governance standard globally.
Meaning you basically meet the EU bar everywhere and then maybe add anything else specific you need on top. Exactly. Aim to meet the EU requirements everywhere as a baseline. It radically simplifies operations, it builds trust with customers worldwide, and it effectively turns compliance from just being a cost center into a potential market differentiator. It defines how those valuable data products are governed globally for maximum trust and impact.
An essential thought definitely for anyone building systems today. Well, thank you for walking us through all these architectural layers, the performance needs, everything that really defines AI success beyond just the model itself.
My pleasure.
We really encourage you listening to explore what AI-ready data truly means for your specific systems. Until next time.
Spoken Tech for your ears.